Hi folks, in today's video, I'm wrapping up my talk from Bixby Winter on powering passive optical networks. In my last two videos, I described what a passive optical network is, presented the two main ways to power them, and reviewed one, local powering, in detail. The links to both videos are at the end of this video. Today, I'll review remote powering. Remember our two-building example from our previous videos? Let's move to our office building. There's no OLT here or optical line terminal, just fiber from the hospital's OLT. There are splitters used to feed all the ONTs or optical network terminals in the building. Let's use a centralized power system with battery backup, power limiters co-located with the splitters, and extension cords to power the remote ONTs. Per the National Electric Code, Class 2 circuits are below 60 volts and limited to 100 watts max. Cables for such circuits can be run in open cable trays or anywhere without conduit, by anyone. No need for an electrician. Because of this freedom, we'll opt for Class 2 circuits to power our extension cords. The power limiters are DC to DC converters. Their input voltage can move around, like on a battery plant, while the output stays set. In our case, that output is set to 57 volts DC. The input will move as the battery discharges, all the way down to the discharge level of 44 volts. For our extension cord topology to work properly, their input needs to remain constant as the battery plant discharges. Sizing the cord is simply Ohm's law. The maximum load at each ONT is 72 watts. The minimum input voltage is 46 volts. So the calculated current draw is 1.57 amps. The voltage drop across the extension cord must be less than the difference between the output of the DC to DC converter and the minimum input voltage for the ONT, or 57 minus 46, or 11 volts round trip. The maximum resistance of the entire length of the cable must not exceed this voltage drop divided by the maximum current draw of the ONT, or 11 volts divided by 1.57 amps, or 7 ohms. That's 3½ ohms one way. Cables with copper wire for power and fiber strands for communications are known as hybrid cables. They typically come in copper gauges from 18 to 12, 12 being the lowest resistance. Of course, you're free to use a separate copper pair of whatever gauge you wish. That's up to you. And it's not uncommon for the fiber paths to be different from the extension cord paths, so hybrid cables are not required. If the maximum resistance is 3.5 ohms, a 12-gauge extension cord can be almost 4/10 of a mile in length, or over 7 football fields long. The pros of centralized powering are: the power gear is centralized, as well as the batteries, and Class 2 circuits can be used. The cons are the need for the copper extension cords and their length limitation for very long runs. As always, if you'd like help powering passive optical networks or anything needing power, please give us a call. We're here to help. Thanks for watching.